Scenario. A diagram shows the ball of mass m being swung on a rope by a person with mass 70 m that is rotating counterclockwise. Assume the person's arm rotates without friction and the rope's mass can be ignored. Describe the total angular momentum of the ball-person system. Question. When the rope length decreases. So it should be when the rope length decreases, what happens to the total angular momentum of the ball-person system? Let's take a look at the answer. Well, this action will decrease the angular momentum of the ball because the R goes down, but it will increase the angular momentum of the person. That decrease of the ball's angular momentum is offset by the increase in the person's angular momentum. But if you look at the ball-person system together, like the question says, there is no net change. The initial angular momentum is equal to the final angular momentum of that system. It is just change or transferred between the ball and the person. Likewise, the next question asks when the rope length increases. Now the answer just switches. The increase in the rope's length will actually increase the angular momentum of the ball. That increase in that angular momentum of the ball is offset by the decrease in the angular momentum of that person. So it was transferred between the person to the ball. But if you look at the ball-person system together, there is no net change. The initial angular momentum of the ball-person is equal to the final angular momentum of the ball-person. The last question asks, what about if the rope is actually swung in the counterclockwise direction? Well, before it was counterclockwise, now they want to swing it clockwise. So you're changing that direction. Well, the change in the direction won't actually increase or decrease the magnitude of the angular momentum because, again, there is no additional velocity that was introduced into the system. The only way for you to actually change the total angular momentum is that if a net external force is coming into the system or a net external force is doing work onto the system to increase its energy, right? To increase its velocity amount. That is the only way you can actually change the total angular momentum. If not, this system just follows conservation of angular momentum.